Okay, so today we're going to talk about domain and range. And like everything in math, there's always an opposite. And so domain and range are opposite with each other. And what do we use them for? We use them to represent different parts of a relationship. In this case, when we're looking at functions. So domain is the set of all possible, and if you haven't noticed, I'm in your Math Interactive Digital Notebooks. You can go right to those pages and type it in. Domain is the set of all possible inputs or X values. I'll just put X. And other possible names for this would be X coordinates. Of course, what we just said, in inputs into a function. And lastly, independent variable. Okay, when you're independent, that means that you can act of your own contrition, like you're not dependent on something else. The something else is dependent on you. So the opposite of that is the range. So if domain is the set of all inputs, range is the set of all outputs. Or the opposite of X value would be the Y value, or the Y coordinate. So other possible names for it will be the Y coordinates, outputs. An opposite of independent would be dependent variable. Okay, so those are what we talk about when we think about how do we record this information, right? Like that's what we're going to talk about next. How does inputs and outputs, how do we look at that from representations? So going to the next page in your digital notebook, first let's look at ordered pairs. So here we're just given sets of ordered pairs, and how do we determine the domain? Well, I always like to refer to the alphabet because when we think of X and Y, I think of A and B, or, if you go through the alphabet, X comes before Y, so domain before range. I also think about just the letters, D for domain and range for Y. So D comes before R in the alphabet. So in other words, when I'm looking at a coordinate pair, the first piece is going to be from the domain and the second piece is going to be from the range. So when I look at these coordinate points, 0, 3, 1, 5, 2, 7, and 3, 9, the domain is going to be 0, 1, 2, and 3. We're going to find out later on, while it's really important to distinguish between the two when determining if something is actually a function or not. So 0's here, 3 must go here, 5 must go here, 2's counterpart is 7, and 9. So from ordered pairs, the first part, domain, second part, range. What about for a table? Well, usually tables may be marked X and Y. And just like you read up to down, or you read right to left. So in this case, we're looking at a table that moves sideways, but if we had an up and down t-chart, the X values would come first and the Y values would come second. So the same thing here. So the X, we have -1, 0, 1, and 2. You'll notice another thing, all of these for the domain go largest or smallest to largest. So that's consistently what we want to do is we want to have the smallest value number first and the second value number second. So when I look at the range, I could put this in this order, but I'm actually going to order it as 0, 2, 4, and 6. And that's because I want to go smallest to largest. Because right now, these aren't matched up. I'm simply saying that these are members or elements of the domain. They're X values. These are elements or values of the range. I'm not specifying that -1 needs to go with a particular number over here. Lastly, when we're looking at graphs, we have two different types of graphs. We have discrete graphs and continuous graphs. So with discrete graphs, they are simply points on a coordinate plane. Oftentimes, they might be called scatter plots because they're not connected, right? It's not looked at as all these little spaces in between are also points as part of the domain and range. So here, domain, I should know that the X value, right? You're laying down before you're standing up. So horizontal, vertical, same thing applies. H comes before V in the alphabet. So how do I figure out the domain values? Well, I literally go to a point and then I go up to the breakpoint or the origin or the axis line. And I can see that this is at -1, 0, 1, 2, 3, and 4. Might need another spot here, actually. So -1, 0, 1, 2, 3, and 4. And I'm surrounding these with brackets, right? The brackets tell me that this is a set. So down below, to find the y part of it, I go to the side. So for this here, 1, 2, 3, 4, 5. This is at -5. I'm skipping 2, so -3, -1, 1. So we're going up by 2, starting with -5, -3, -1, 1, 2, or 1, 3, and 5. Actually, it's going to make this a little bit smaller to fit it in my bracket. Take up a little bit more space because of the negatives. Okay, so that's it for a discrete graph. Now, for a continuous graph, it's going to be a little bit different because when something is connected on a graph, this isn't a point, and this is a point, and this is a point, and this is a point on the graph, but all of these little ones in between are also points on the graph, so I need to account for them. So it's not just this one point, it's all of these points. So first I need to look and see, to determine my domain, right? It's horizontal, so I figure how far do I come out on one side and how far do I come out on the other side. So looking at this just side to side, imagine if you built a box around the exact points that you see. The furthest point over here is 1, 2, 3, 4, 5. So -5. And it's not an open point, meaning it's not an open circle. It's a closed circle, so it includes that point. Then going over here, I can see I have this arrow. And what this arrow tells me is that this line would keep on going. It would never stop. So in my domain, I'm actually going to identify this with a square bracket because that means to include something, whereas an open parenthesis means that it's up to that point but not including. So I need to start at -5, and it's going through infinity. I'm going to have to do a special character here. Of infinity. And if I want to get really specific, I can even say it's going through positive infinity, right? Where this is heading towards the positive. If I was going this way, it would be heading towards the negative. And I'm just talking about how far I'm moving side to side. So if I keep on going out, I'd be going 5, 6, 7, 8, 9, 10, etc. Because that's going to be a little different when we look at the range. So for the range, we look from top to bottom. So from the top, the furthest I go is 1, 2, 3, 4. And again, it's included because this is a close point. So from positive 4 all the way down, and it keeps on going down. And if I'm going down, that means I'm getting more negative. So where my range starts at, because I want to go smallest to greatest, copy this down here, is actually negative infinity. So I'm going to take that out and put a little negative. And it stopped at, we said, positive 4. Now you'll see that these brackets are here. I actually don't need both these brackets and these brackets. All I need is one set of brackets. I'm going to put another closed bracket over here. So this piece right here is how I would write the domains and ranges for continuous graphs. And domain, remember, I want to like essentially box this in and create like how far do I go on one side to how far I go on the other side. And then for the range, I'm looking how far up I go versus how far down I go. And that is how I record it. So the next thing you need to do for today is you need to do your guided practice page, which is slide 13. And you can see here, it's just asking you to do the same thing we just did in the examples above. Find stuff for ordered pairs, tables, and then 2 sets of graphs. One's discrete and one's continuous. And that is it for domain and range.